All right, we're back. We're back. Thanks for watching. Thanks for joining. So we're back with more coding. Same DiSco MIMO project. We really have to reproduce that training. Actually, let's pull up our favorite thing here. So here's what's gonna happen is today we really have to push to get everything in the paper going, get all the training. We're pretty much there. We have a loss, we have inference, we have modern architectures, we have data generation, loss function, inverse problems. We could not reproduce the training though last time. The loss has to go down faster. We got to fix the sampling too, but the reason for the urgency is that we're actually gonna do something interesting. If we're successful today, and it may be a long stream or a long series of videos if you're on YouTube, we're gonna write a paper about what we did and submit it. The only thing is it has to happen today and or tomorrow because the deadline is Tuesday. So we have a lot of work ahead of us. So let's get right back to it. Now, where we left off last time, let me see if I remember. Where we left off last time is that we have everything, but the loss is not quite going down. I know we managed to improve the loss a bit. Oh, and we switched the architecture to this. We kind of tried to do NCSN v2, but we didn't really do NCSN v2. We did this score SDE PyTorch repo. What I'm thinking today is two things. Okay, so let's see. UV run -- group torch -m MIMO train. What I'm thinking there are two things. Check the training data, and we can actually use the training data from the other repo, okay, just to see if that's the problem. That's thing number one we'll do. Depending on how that works out, we may actually use the NCSN v2 model. I don't think it's that though, because we really are using, let me see what we have for default now. So I believe the default model should be, oh, there it is. It's Arch NCSN v2. So then it just goes to NCSN v2. Which is NCSN v2 imported from Score SDE PyTorch, which is the installation of my fork. Oh, it's loading the torch kernels. That's why it's slow the first time. And this is really, it's a very similar model to the one in the paper. Now, it's not quite that, but we have a problem here. What did we do here? Oh, there's a local fix. Oh, yes. I forgot to do a local fix. Okay, so we caught an error. So let's fix this quickly. So bias.data, if I remember correctly. So what I have to do is, I'm gonna have to work in the other repo. And I know there was an issue last time. Okay, so we can move to Score SDE PyTorch. And if we look at models, let's see. Bias.data, where is that? No, it's in layers, right? Bias.data. And this should only be if bias, because modern PyTorch has changed something. Anytime you try to access, here we go. So this should be under if bias, okay? So now that we're gonna do this quick patch here, let me see, where are we here? Get status, we're on main, right? Yes. Okay, so we can just commit this. Only use bias when true. And we commit this file. My point is to get quickly to the, and we can just push to the main. bypass rule violations because I'm the admin. That's fine. So now we get the git log. We have this new commit ID. The point is now to take this, now move quickly, go back to our, and this is all possible because of UV, obviously. So we go back to DiSco MIMO, and then in the UV environment, we can just say, I now want this commit ID. And that's it. I should do UV sync, group torch. What does it remember? Okay, there we go. Now it worked. Last time there were some, I think there were some GitHub issues. It must have been GitHub issues. Okay, nice. So now we actually updated this, and we should also relock and recommit this. Bump model fix. Now this is all nice and good. I'm still in the NCSN branch, but the problem is now we can try again now. So that's how we do a fixed and a principled way. Let's try training again now. Okay, so it well, this is a new one. I have not seen this. I wonder what's happening is, was I getting tricked last time with an invalid model? So let's see what's happening here. It's still a core NCSN v2 issue. Layers line 499. Can I open this? NCSN v2 layers line 499. So I can't go through the residual block because interesting. Calculated padded input size. What size data do I have here? What am I trying to do here? Did I mess with the data a bit? I really don't think so. Let's see. Breakpoint. Let's try this again. Okay, so there are some issues. Maybe if we fix these, we'll be much closer then. Interesting that I didn't see these last time. So batch noisy.shape. Yeah, this looks about right. 1664. And model is NCSN v2, right? Yep, it is NCSN v2. So it's a convolution 2D with kernel size 3.3. Where's the kernel size 9.9 coming from? Why am I even seeing that? There is no kernel size 9.9, right? You would think. Yeah, there is no kernel size 9.9, obviously. No biases, that's fine. Stride 1, padding 1. So I never eat anything on the side. 6464. It's just a constant size. I guess, does it go to 128 or? Oh, well, this is pretty bad then. Why am I getting... I wonder what was I doing wrong then last time. Interesting. I mean, this makes sense, but who is giving me a kernel size of 9.9? That's what I want to know. So then if I stop at 499, what do I have here? Let's see. Yeah, so because we have to prepare for this paper thing, I may go a bit faster, but that's probably fine. I'm 1664. I guess this is not the issue. Again, I'm fine. 832. 416. So somewhere, okay, so then we can do this then. Try except breakpoint. Let me catch this exactly, 'cause something is fishy here. So let's see, output.shape. Yeah, this looks about right. What is conv1? Oh, dilation 4. Okay, there we go. So it's a dilation bug. Okay, okay, gotcha. Who is setting my dilation? Dilation. There we go. That's the bug. Okay, that means I must have not fixed this then. Interesting. Okay, so then what we have to do is we have to stop here again, and I need to inspect the model a bit to catch the dilation. And then we'll switch back to the other repo, commit again, dilation 1, that should do it. Now, where do I have dilation 4? Dilation 1. Somewhere here, dilation 4 leaks. There's a kernel size which is a bit suspicious here. I guess 5 padding 2, that's fine. Oh, here it is, dilation 4.4. Okay, there's a ton of dilations 4.4, and I'm guessing before is fine. Yeah, okay. So I must have leaked some dilation somewhere. Now, where did I leak it? Dilation is 4. Nah, we're not gonna find it that easy. Oh, but wait, I know where I leaked it. I leaked it in, where was it? Residual block, was it? Something like that. Here it is. Yes, in a residual block. And who gives me residual blocks? NCSN v2. There we go. Residual block. Dilation 1. Oh, here it is. 4.4. Okay. All right. This is fixable. That's it. Okay, good. So now what I can do is same thing. All right. So this is how we do fast development. I'm just going to open the repo again. And I actually have the model here already. And I go dilation 4. There we go. We want this to be 1 because we can't afford this size. And we go get status again, and we go get add score models NCSN v2, get commit, use dilation 1, push, again get log. This is the commit we want now. So we go back to our repo. We don't need the internals anymore. Back to Pi project, we update the repo again. Now I can't let it just use the main, but I want it to be pinned. Okay, there we go. So it pulled the repo, it resyncs everything. Again, it updates. Let's try again then. Any other issues now? We don't need breakpoint anymore. We do not need breakpoint anymore. This should make it run through. Okay, there we go. So it's running through the model. Now this is okay. So everything is good, except it's not really good. The loss is going down, but it's not going down like in the original repo. And we can confirm that. We should confirm that next time, actually. Next step, I mean. Yeah, there we go. And it's plateauing too at 600. This definitely doesn't smell right. Yeah, it's oscillating too. From what I remember, and we will confirm this again, we can just go and train the other model. And we did this actually because when we modernized the old repo in before this series, so in about 1,000 steps at batch size 128, which is also not the paper, it should be 32, but that's fine. It's also producing some data. Now I have two quarrels here though, because I also have a quarrel with how the training data looks like. You see these lines here? That tells me there's a wrong IFFT shift or something applied. This data looks like split in 4 sub-images, and it should not look like that. Yeah, the training is stuck now, right? So training is oscillating at 500. This should not happen. This is what we have to fix. And it's either, I suspect it could be the data. If I try batch size 32, max noise level. So let's take a look at the reference code then. So let me do this then. Let me open that repo. Here we go, score-based channels. And we can train score. And if I remember the command correctly, we just do a UV sync. Okay, so the sigma begin is different. It's 39.15, the rate is 995, and there's 2311 levels. This we can make. EMA doesn't really matter because we saved the non-EMA model. Non-linearity is ReLU. Interesting. This I must have slipped then. But it's not the same neural network though. Learning rate is 10 to the minus 4, which is also a bit smaller. So there are a few details. I think all these have to be nailed. But before that, so let's confirm that the training works here. Yeah, batch size is 32. CDLC. Okay, so then how do I train here? Because if I remember correctly, it's a UV run -m score based channels .train.score. And I should see a loss go. There we go. Starting training on device. Okay. I'm curious to see how the loss does. So we're gonna have to start looking at details though. I'm pretty sure it has to be the data though. Nice. So now we're gonna plot every, what, 50 steps, 100 steps? How often do we plot here? I think it's like every 200 steps. Where's the plot? Oh, it's every 100 step. Okay, perfect. 100 steps. So it's kind of similar to the other one. Okay, so the training loss is 916. So it starts about the same value. At about the same value, but I do distinctly remember this going down faster. Could it be that the model is too? Yeah, there we go. So we get 667. And this is a running loss, sure. But even so, that means it's more pessimistic. Yeah, it goes to 537. So that's one epoch down. Okay, maybe I need to leave this run for a while. Yeah, 465. Okay, so if I remember correctly, this should stall out in the 10s. So the training does progress a fair amount, which is definitely not what we're seeing. Also, I need a validation loss. Yeah, there we go, 417. Validation loss going down to about 5 hours. Sounds probably overkill. 395, 789. Yeah, the validation loss is just the validation loss. 384. Is it really gonna stall out too? Am I misremembering things? Like, this is the curve? No, it's gonna keep going down. Okay, so while this is training, I have to, let's tweak ours a bit then. Rather the new one. Okay, so the new training, so I messed up the learning rate. Let me just use the paper then, right? So the num noise levels, 2311. And do I need a min? What do I do with the min? Why would I specify? So I don't specify a min. Instead, what this should be, it should be the max times the rate noise decay, noise step factor, okay, to the power of number of noise levels minus 1. So then I don't need a min anymore, because I think this min noise level yeah, I need to compute the min. Okay, so I have to do the same trick here. Yeah, this is clearly going down after 1600 steps. I wonder if my network is too small then. Okay, so this is kind of fixable. Let's not despair then, because this is definitely fixable. So first I'm going to use this as my min. So I'm not going to have min noise anymore. I'm just going to use this as my min, which is computed by a formula. Okay, then I'm also going to have a rate, which is called the noise step factor. Well, actually, it's this whole thing. I don't need to compute it anymore. Okay, and that's it. Then I don't need to specify the min anymore. I just specify the noise step factor, and it is 0995. Batch size 32, learning rate 10 minus 4. This is starting to look very, very similar. The loss I'll do every 100 steps. Okay, I'm just gonna turn off all the sampling. And let's also plot. So maybe the loss is not going down not as much as I remember then, right? It's only 200 something? Because then I'm pretty much basically there. So then it's just a matter of tweaking the data and sampling, which would be nice. But the problem is my model is smaller though, for sure. All right, so before we, okay, so let's not get lost here. So we fix the, we start from 39.15 with rate 995 for 2311 levels. Good. EMA rate will not matter. I'm not gonna tweak the Atom betas, they don't matter that much. Yeah, there's no way this is that sensitive, or else we're in, maybe the Atom epsilon. What is the default Atom epsilon in PyTorch? Where the heck is Atom? Oh, come on, it's not here. Oh, it's not here because the code thing gets it by itself. What I need is I need to plot the validation loss too. So here, so I have validation samples. So let's compute validation loss. And what is it? It's val loss. Do I have here it is. Output noise standard deviation square. So I kind of need this whole process. Whoops. Because I did split this up a bit. It's not that bad though. We'll modularize this later. I really need to get this working though. So we pick some noise levels. The batch now becomes val samples. We apply val samples noisy, okay. Convert them to real, complex to real. Pass them through the model, yes, with this standard deviation. Convert it back. Compute the loss function, so val loss. And we have to print this. Where's the print? Hey, thanks for stopping by. Trying to get this paper going because doing good. I actually want to submit, well, trying to finish reproducing this PhD paper. I'm actually going to write a paper on this and submit it to a conference. And I'll do that on stream too, hopefully today or tomorrow. The only problem is I really have to reproduce the paper now. If that's successful, then I can start writing the paper because I found this conference on reproducibility. And I'm actually going to sort of write about this YouTube series in that submission, which should be pretty interesting. Yeah, so thanks for stopping by. I've seen you around. Feel free to ask or just lurk around. I really got to get this. Something is fried here because right now I'm running the old code. So the loss kind of goes down to about the 200. I cannot get it to go down. And I've noticed the difference. I know I have difference in model and data. So we got to fix that. We're getting there. Okay, so what do I have here? So after 3,600 steps, the loss in the reference code, the loss is about 200. And validation loss starts to catch up. So then the first thing I need to do is... Now, let me delete this then. PyTorch is just a Python package. It's pretty much what everybody uses for deep learning these days. So I get the training loss. I need to print it. Oh shit, how was I printing it here? Okay, so loss function. So we need to do this print nicer. So it should be something like this. Step. We can ditch that. Train loss. Should be loss.item. Does the deep learning take you into outer space? I'm not sure about that. Not really. It's more grounded than that. And then I need to plot the validation loss, which is validation loss.item. Okay, I can ditch the Recon MSC for now. I don't need this yet. Okay, so I know this kind of stalls out at about 200 then. Interesting. I'm actually curious about one more thing then. Let me think about it. UV run Python. So if I go file name, where do I have this? Do I have a model here? It seems like I do. Interesting. Models, score, CDLC, final underscore model dot pt. And I can do torch. And I can load this. And I do map location CPU. Yes, I do have the loss. Okay, this is really good because now it tells me this is a file from like 5 years ago, but it tells me exactly. Let's check this out. This will tell me exactly how training went. Yes. Okay, good. So what is the last training loss, or the last 10 training losses? About 100. Okay. So now I know what training loss I need to reach. So it's about 100. And the validation loss is also that, I would guess. Yes. Okay. So if I got the loss right, I don't need to train this anymore then. Because it kind of reaches it. I mean, this is useful because it tells me how fast it reaches it. So after 6,000 steps, I'm getting there. It's like 184 and 214, which is pretty good. 184, 186 after 5,600. Yep. Okay, good. So I don't need to run the old repo anymore because I found the exact logs, which is really good for reproducibility. So about 100, about 184 after, about 180 after 5,000 steps. Okay, we need to remember this. Okay, I can switch back now to the working repo. So I did a bunch of changes here. Change the levels, the batch size, the learning rate. What else can we change? Let me see, go back here. Are we confident that the loss is correct? Output val loss, score training loss. And what is the loss I had in the paper here? It was models. No, it wasn't. Where is it? Ah, shit, it's from the NCSN v2 repo. So NCSN v2 losses DSM. Let's see, so labels is none. So we sample a random noise level. This I do on the outside, okay? I pick the sigmas, which is exactly the noise levels. Exactly. I sample noise, which is random-like, which I do here, and add noise to data. But I'm in complex world here. So I put the square root of 2. And then I just add it. Minus 1 divided square. Oh, am I so dumb? It's just a half here. I found the bug. So we really are reproducing the paper. Damn, the loss is halved. That's it, because so it's half times square norm, which is sum of square differences, like here. Times the sigmas. Which is a coefficient for each of them. What the heck is coefficient? Squared sigma. Yeah, sigma to the power of 2, because this anneal power is always 2. So I should hit this with vector times vector then, if I stop here. I think we got it. I think it's just that stupid half factor. Interesting. So loss dot shape. Yeah, so this coefficient dot shape. So I hit it with vector times vector. But why is my loss so... I guess it depends on the noise level too. Yeah, I see. So higher noise levels get coefficient. Yep, this seems to be right then. Okay, so we fixed the coefficient of half, which also halves my learning rate. We fixed the batch size, everything, the sigmas. When I get a model... Not too happy about how this data looks like. Did I say in the paper how the data should look like? Because I feel like there should be a table here. I really hope there is a table with stuff in here. There is a table with stuff. It says carrier frequency 40 giga, 40 gigahertz. ULA lambda over 2, 1664. I think I know what else is happening here. Okay, let's trigger another training run then. UV run, where am I here? MIMO train. No, it's not converging as fast. What, so this is even after the halving? Yes, it's even after the halving. Oh wait, what am I printing here? What loss function at? Oh, okay, I don't want this, yeah. Well, maybe I do want that actually. Hang on. It's not going down as fast, or is it as steady? Maybe it is. Let's hit 200. Nah. Oh, it's kind of swirling around. Yeah, okay, so something is fishy here because the model is so much faster. Then I really need that other model then. That's difference number one. Difference number two is I also need to make sure the data is right. I can't crack this one. Okay, so we have to stop this.